Okay, let's begin our lecture, which is actually, give me a second, I will complete. So I have sent this homework quiz on chapter 4. Okay, as like I also have sent all the homework quizzes which are related to each chapters. Okay, so somewhere the related questions only comes for your continuous assessment as well as the semester one. So it's better you to practice now itself with the homework quizzes. Okay, with and also our notes. Okay, actually, we are in the chapter number 4, which is the application of the some of the famous PDEs, which are heat equation, wave equation, and Laplace equation with some boundary value problems that I also explained in our earlier lecture, which has some boundary conditions as well as the initial conditions incorporate with these equations. Also, we also have used Fourier series, which we have used it, but the full entire course will come in your following semester. So you can also study very well about it. I just used in the last point. So it's better you to understand that concept here, then use it in the exam. Then you can learn full about it in later part. Okay. And also, what else? Okay, in last lecture, I have explained you how to solve the one-dimensional heat equation. Okay, so hope you have understood that thing. And also, if you go back to these homework quizzes, okay, but my plan is actually I have almost finished everything, but I wanted to show you some related questions which you can get in the chapter number 4. So today we'll have some examples and things and finish up our lectures today. Okay, everyone joined? 48, 45 only. Okay, so this is how the questions may arise. Okay, using the separation of variable method, solve the following PDEs. Maybe this is a one, mostly in this, coursework, we are introducing the one-dimensional heat equation. I also explained you what will be the next, second dimensional, third dimensional, okay, equation, just like, we are having other dimension spaces. For example, in here we have only x square. So if it is two-dimensional, we have, so we have this equation can be like delta u over delta t as it is. Okay, in the case of heat equation, okay, alpha squared with delta squared u over delta x squared plus delta squared u over delta y squared. Okay, this is a two-dimensional case. Okay, so nothing will change much. Only a small thing in this derivation will change. Okay, and also you can see in this question why I have chosen these two equations under the one-dimensional case is, see here, both are for the one-dimensional heat equation. But the thing is different is only the boundary condition. See here, even the initial condition I have taken fx. Fx may be, I told you, maybe any transitional function, any function of x. For example, sometimes they may use algebraic equation. For example, x square or x. Okay, fx can be any of these. Okay, according to the question, they may check your knowledge according to this one. So in last lecture also I have explained to you how to derive all the things, but this point we have used at last, no, at last point only we have used the initial condition. But when the derivation, the boundary condition used, okay, and the last point, that Fourier series kind of thing only we need it. Okay, for example, Bn is our point what we need to find. There only we have, for example, 0 to L, fx sine mx by x over L dx, something like that. So you can have something, this one, no? For example, let's say pi x over L dx. Okay. So see here, what kind of equation? This is only the knowledge of integration. No? So integration in the sense, this is kind of a UV form of the integration. So you know that one, no? It's kind of a islate, I told you in our elementary differential equation as well. Do you remember? Okay, can you elaborate me what are these ILATE? Let's see, you still have that knowledge. I think you may also use in the OD also, no? Can you elaborate what is I, what is L, what is ATE? I hope you know. Can you answer me in the chat? Just abbreviate these, give the explanation of this abbreviation. You can also Google and tell me, at least, if you forgot. I saw some of you has used in your elementary differential equation solving in your assignment and continuous assessment. I saw some people have written these. Tell me, you can Google and tell me. Yes, good. I got one answer. Yeah. What about others? Everyone, just Google it. Islate rule, like that, and tell me, at least if you forgot. This is how you study, no? Now only we are studying, no? You can use anything. But in the examination only, you have to memorize these. Good. I got 2 responses. How about others? Okay. Okay. I got enough. So it says I is for inverse functions, L is for logarithm, A is for algebraic, T is for trigonometric, and E is for exponential, isn't it? So in the sense of you have learned the different functional type, no? So you are in the second year. So first year full, you have gained some knowledge about these things, no? So maybe in inverse function, maybe trigonometric inverse or any inverse, like sine inverse can be also comes, okay? Oh yeah, like kind of. Any next one, logarithm, okay? Log of x if comes, okay? So trigonometric, maybe sine x, okay? Next one, sorry, algebraic means x or x square minus 1, any of algebraic equations. Exponential in the case e to the power x, some kind of exponential function, okay? So see here, what are the functions available here? So x in the sense, we know it is kind of a algebraic. Sin x, t. So what you have, why we use the islate? So we have to, okay, I can use, give me a second, whiteboard. So islate in the sense n sine by x over dx or something. Okay, this is our bn. How to solve it? That's our things. Okay. So here, islate in the sense algebraic come first. So the order is this way. So choosing the u only, we are using the islate. So I guess you remember the solving method of UV form of integral, isn't it? So what is that? Second. Okay, what is the the way to solve integration of UV dx or something? You have to take u into So it's kind of a dV, no? U dV, which is equal to uv minus integral of du. Is that v? Yes, v into du, no? V into du, am I right? Please correct me. uv minus integral of v into du. Isn't it? So can you correct me? Am I right? udv uv minus, isn't it? Yes. So you have to take the u from this. Okay. So algebraic one, this one will be, okay, I'll use another color. So this one will be my u. This one will be my du. I mean dv. Okay. So from differential dv to v, how you get? If you get integration, isn't it? So if you integrate the differential equation, so it is kind of a inverse function, like x into 1x kind of. So you can cancel out, the original equation will come. Okay. So differential equation and integration are like an inverse case. Okay. So if you have integration of dv, you will get a v. Okay. Original equation. So that sense you can use here. Then you have to take the du, you have to differentiate whatever the u have, and v, you can write whatever the v you have gained from here. Okay. So I don't want to teach you these things. These are, A-level stuff. So hope if you are not clear about it, go back and study yourself. Okay. So when you are solving for Bn only, you need this. Okay. So that is kind of the Fourier series concepts. Okay. To find it, they have used the Fourier sine series concept, and we got it. Okay. So that's that. Okay. So let me go back. Okay, so what I wanted to teach you is, so this fx is okay. Both are fx. So according to the x case, function of x, you can solve the initial condition. The thing I wanted to show you is, see here, the differential, boundary condition types. So see here, both, I told you the one-dimensional heat equation has been derived for the rod, one-dimensional rod of 0 to L, length of L rod. Okay. So they have given what if at x equal to 0. So in this one is a x direction. No? The next one, they are considering the t. T is for time. So in the space while they are analyzing the dimension. So one dimensional means we are only considering x. So if it is two dimensional, you also need to consider some kind of like a two dimensional, let's say bigger, like a cylinder is kind of a two dimensional, isn't it? So in the xy plane. Okay. So that's we are omitting for now. But if you're interested, you also can be learn that. Okay. That is coming maybe in if you are doing some special or MSc, all those where you can learn the higher dimensional things can be solved. Okay. Not only the separational variable, there are so many techniques you have learned to solve the ODE, PDE. We can also use so many different techniques, isn't it? So numerical techniques. So this is kind of algebraic techniques. Okay. So see here the difference, but I wanted to teach you. That's why I put two questions in here. Okay. So see here, both enter, they say 0 degree. So it kind of, initially they say both enter in the ice cube. Okay, let's say if the ice water or ice cube is what? Like a 0 degree, no? So it is kind of a 0 degree Celsius. Okay. So the temperature at 0 and L. Let's say our rod is inside both end up inside the ice cube. We are heating now here. Okay. And what will happen? At time is equal to 0. What is the temperature? At time is equal to 5 minutes. What will be the temperature? Let's say time is equal to 2 hours. What will be the temperature? This is kind of, the things we are. So this is coming under, physics also. Okay. Or otherwise, it's a practical thing in the physics. Okay. Here we are numerical, what I say, mathematically we are solving. Okay, so this is, if you wanted to do these things, this is the simulate, we say simulations. Okay, around different time or different parameters, what will happen, we call it as a simulation. You can learn, next semester you may have one of the software. Okay, there you can learn how we can get different solution and different I mean graphical representation also. Okay, so those are I mean you can learn. You are just only in the second year first semester now, so later part you will learn all these things. So here what I wanted to tell you is, this is kind of a equation, both end are 0 degrees Celsius or 0. Just normally this put 0. Okay, this is we called one of there are different, see here in this one they say insulated boundary condition. Okay, so you can also yeah, here I have gave you a simple description, only mathematical description. You can also see in the some books or even in the Google, you may find some question which is something like a sentence, I mean paragraph. So you have to derive this mathematical form. Okay, so if you are interested, I can also read you. Okay, I didn't put because I don't want to make you harder more, because we are almost finished. I don't want to make extra effort here, so that's why I just put the mathematical form. So if I wanted to elaborate this in a sentence, okay, this question may be like, the faces x equal to 0 and x equal to L of an infinite slab, or rod also can be said as a slab. Okay, the rod or slab. So this is one of the question I have derived in this form. Okay, I'll read it. Okay, the faces x equal to 0, x equal to L of an infinite slab are maintained at 0 temperature. Okay, given that the temperature u x comma t is equal, x comma 0 is equal to f of x at t is equal to 0. Determine the temperature at the subsequent time. So this, that kind of question paragraph I have made you a simple way. Okay, so even though if you get like kind of question also, you can, after reading that one, you can write what they say, the both end are in the 0 degree and initially it is a function of x, something like that. Okay, in a sentence. Okay, anyway, no problem. The thing is how you are solving, no? Yes, so there are that is out of the course anyway, I'm telling. Okay, the boundary conditions, there are 3 main boundary condition has been defined, which is one of the cases Dirichlet. Okay, Dirichlet boundary condition. Dirichlet is one of the person who, this is kind of the Dirichlet form. Okay, or both are 0, which also known as homogeneous. You know this homogeneous case now. So if you are having the right side 0 case, we call it as homogeneous. So both are 0 boundary condition, we call it as a Dirichlet or homogeneous boundary condition. Next one, if you have an insulated in the sense, you also have the derivative of 0 comma t. Okay, derivative of ux comma l comma t. Okay, not the normal u. You have the derivative insulated. Okay, so which is known as, I guess, Newman. Okay, so you can also refer. Okay, Newman boundary condition, the Dirichlet boundary condition. Newman is one of the person. He found this kind of Newman boundary condition. Also another one we call mixed one, mixed or Robin boundary condition. Okay, so that means one of the end, let's say 0, other end with the insulated one. Let's say like this, both are involving. This is called a mixed one or Robin boundary condition. Okay, so this is out of your course anyway. So if you get like kind of question also, so the thing is when you are deriving, so this derivation is different than this derivation. Why? So in our last lecture, I have told you this derivation only, isn't it? There in the derivation, I have used this boundary condition now. So you have to learn. This is your homework. Okay, find the way to find how to solve it to incorporate the insulated boundary condition. Okay, so I think in this question I have derived Yes, second. What is my last equation for this one? Something's ux comma t, which is equal to summation of bn. Do you remember? Bn sine n pi x over L exponential of minus alpha squared n squared pi squared over L squared t, isn't it? So this is the answer for this one. Sometime for this one, maybe not the same. Something like, for example, let's say, I don't know, I don't have that answer. Anyway, I'm just this answer. So for the, give me a second. Okay, this one is a Newman equation. Let me see. The answer may be, I don't have a full answer. I'm just, let me say summation, maybe a naught by 2. Okay, sum of the another. This is kind of a Fourier cos series you have to use. This is for Fourier sine series. Okay, a naught by 2 summation, but I'm not sure this one, but you can find out. Okay, something, let's say bn cos n pi x over L e to the power minus alpha squared n squared pi squared over L t squared t, like that. Okay, maybe cos inverse for this one. So that is your homework. You just find out. Okay, so that's your reference. So I have told you the one-dimensional heat equation with the Dirichlet boundary condition. So similar way, same idea, but the boundary condition only not changing. So you can find this answer in the Google or even any form of in the books and anywhere. Okay. So find this. I'm not sure this answer, but just try it. Okay. Okay. So shall I continue? Okay, just note down and find out the proper answers. Okay. All right. So is this okay? So we have completed the first question. I'm just going as like a discussion. Okay, I'm not giving the full answer anyway. Okay. Today, did you find the answer for the wave equation? I have gave you as a homework yesterday. I mean, last lecture. For the this is sorry, this is our one-dimensional wave equation. You remember? One-dimensional wave equation in the sense it will be like UTT. Sometimes they will give you in this form, or otherwise they may give you sometimes alpha square, c square. It's not a problem, no? So what do you mean by alpha square? Do you remember? Sorry, this is x. Anyone? What is this actually? Did you find the answer? What is alpha square? Anyone? It's called thermal diffusivity of the material of the rod. Thermal. So alpha or any of the variable, okay? Alpha square. Sometimes they use alpha squared for the calculation purpose, okay? It's a positive number, so they use alpha square. So alpha or C or any K. In some book they use K, okay? Thermal thermal diffusivity of the material of the rod. So according to the rod, what you have chosen, for example, maybe iron rod or aluminum rod or gold rod. Okay, according to the material, it has some different. The physics people know this one, no? According to that, it has a different thermal diffusivity. So according, for example, the iron rod may be heated quickly than the wood rod, isn't it? So on that sense, it has some thermal diffusivity. Okay, so just note down. It doesn't matter anyway. So you have to know why they use here. Okay. Yeah. So next one. This part. Okay. So he see here. So in the wave, in the sense like rod, heat equation. I told you how we heat the iron rod with some boundary conditions. Okay. So what do you think? How comes the wave equation? You can describe. Okay. So everyone studied physics, no? Even in the A level. So what do you think? Wave equation comes where? Like for example, if you fix a wire, okay, then you are pulling, okay, pulling and leaving. So it will be like have some vibration. So vibration in the sense we call it as a wave. Okay, maybe at last it will make a like this moment or some and come back and like this. It has a, or otherwise you may have a this kind of wave equation. This also have some waves. Okay, or in the sea we have the waves. Okay, so like kind of how we can measure those things. Okay, so wave is in sense it can be the one dimensional wave equation has been derived by the string. Okay, pulling the string and leaving, so it will make some. So if you pull further, okay, initially if you have some function, according to the function it has a different answer. Okay, according to the boundary condition. Sometimes if you fixed, we called as a zeros, both are in a zero. So if you have, let's say this is in the fixed, this is in the maybe any rotation or anything. Okay, it has a different. So according to what I said, you boundary conditions, there are 3 boundary conditions now. According to boundary condition also, its answer will be changed. Okay, but here for the easiness, I put only the Dirichlet boundary condition. Okay, but I hope you will go through these things. If you have time, go through all these boundary condition and things. Okay. Okay, now, so we have enough time. So let me do like a recap and do this one dimensional wave equation. Okay. Also, give me a second. Before that, I will go through the next question. Okay. So what do you think? The next question? Okay, next question is find the solution to the equation. This is what kind of equation? Can you answer me? The chat. So I didn't take the Laplace for the time being. Okay, Laplace, if you are interested, Laplace is your homework as well. So Laplace equation, it is little bit of not that much difficulty anyway. Please refer this one. Okay, it is a reference. So I'm just considering the heat and wave equation for the examination purpose. Okay, so Laplace is your reference. So whatever I taught will be in your examination. Don't worry about whatever I have given as reference, but it's good for you to refer before examination. Okay, at least for 5 or 10 minutes, take half an hour and go through any videos or any books, anything, to just go through it. Okay, don't just depend on whatever I have told you. Okay, it's better you to. So if you want A plus or something, you have to go through these things. If you got more knowledges, okay, this will be very simpler for you. Okay, if you go through the higher one, okay, if you go through the 2-dimensional, okay, 3-dimensional cases, this 1-dimensional will be very easy, no? So we can plot you like A marks. So if you wanted to have A plus, you have to do some extra work yourself. Okay. So that's your part. Anyway, can you tell me what kind of equation this one? Even now, if you see this equation, you have to know which kind of equation this. I'm expecting everyone's answer. Okay. At least today is the last class, no? Everyone be very active in this. I'm expecting 10 to 15 answers in the chat. Make it faster. So what kind of equation is this? Very simple question. Is this heat or wave? What is that? That's the question. Do you find it's harder? Heat or wave? Answer me quickly. At least this point of time, you have to know this. How to distinguish. Okay. Yes, the answers. After you answer only, I will continue. Otherwise, I will wait like that. There's no point to go now. Okay, I got 1, 2, 3, 4. 4 answer only. But in this group, there are 50 people here. What about the 50 people? Shall I, off others and only 4 people? Whoever answer only, I will, consider today's attendance. So you are making me angry every time. Okay, I got the answer of 077, 094, 003, 009, 095, 158, 030. So is that all the people are here? Okay. So the thing is, after you find out whether this is heat equation or wave equation, you have to go through the boundary condition type. Okay, this is my Dirichlet boundary condition. So I know the answer. Okay. And then you have to use this, here I have asked you the general equation of fx. Okay. After fx, you just give the answer. You don't need to solve. But here you have to solve because fx already there. No? So you have to know the integral part. Okay. Integral part we don't need to teach you. Okay. So this is we called as a, okay, I will tell you what kind of, function is this. So they say, let's say we have a rod of length L. Okay. So in they say up to L by 2, the half of the rod, we have one initial condition. Let's say X. The other half of the function, we have another function. Okay. So we call this kind of equation as a piecewise. You may heard in the, maybe in the ODE or something, piecewise function. Okay. So it is kind of a 2, breaking 2. So your summation also, the integral also will be changed, no? So 0 to L, let's say Bn is equal to something, fx sine pi x over L, let's say, for example. Okay, you have derived this one. So after substituting, you have to put 0. I'm not going to do this one. I'm just telling the way to do. Okay. 0 to L by 2, you have to put fx x. Okay, for example, pi x over L. Okay, again plus, okay, L by 2 to L, you have to put the other one. Let's say L minus x sine pi x over L. Did you get the idea? And dx. Okay, so these things are two different integral, no? So here you can use isolate, which isolate you have. This is also algebraic equation, isn't it? So two different equation can be added up. Okay, let's say this is A, this is B. Okay, so I can teach you, I can use the whiteboard example. Okay, for example, I have after derive all the thing, you will come to somewhere to find the coefficient of Bn. Okay, let's say 0 to L, 2 over L, something. Okay, fx sine pi x over L. This has been, we know, no, last lecture we have studied this thing. So when you are substituting the fx only, your last part will be, okay, so far in the general case, we have stopped here. Okay, we don't need to do anything. Fx, no, only the common one. But if they give you the effect, you have to solve it further. It's maybe your 10 marks or something. Okay, so 0 to, there are two piecewise, no? So if they give you, let's say, for example, fx equal to x only. Okay, so you can simply put 0 to L x time that I already explained to you, x by x over L dx. This is easy, no? This is also easy. What will happen is you have to divide these piecewise, you may have heard, I guess. Okay, maybe in the A level or something. Okay, dx. The other half, L by 2 to L, you have to use the other. Okay, so that's what that actually that things. Okay, so I don't need to teach you this, no. So you, whatever you find 2 over L, let's say this is my answer will be A, this answer will be B. That's all. Finish. So if they give you here, I guess, let me give it. Yeah. So see here, no, they didn't give you L. Sometimes they may also give you L is equal to 1 or something, okay? That is also you have to incorporate. For example, if they say u 0 comma t is equal to 0 and u 1 comma t is equal to 0, so you have to know L is equal to 1. So wherever the 1 comes, L comes, you have to substitute L is equal to 1, okay? So that's very easy. Try yourself, okay? So this is kind of a, this is also same, no? Same thing. This is also Dirichlet. This also. So this kind of question may come in your continuous assessment or even the semester, okay? So if I ask you in the question, okay, let's say, for example, derive the, so let's say my question is, give me a second. Let's see how we can create a question. I also teach you how to create the question also, no? Okay, first one, let's say my fourth question. So this is how I will create the question. Okay, first question. Let's say this is my first question. Okay, so first question is this one. Second question may be this one, something. Sorry, in this we have the fx equal to common one, no? So the B part may be, the second part may be this kind of question. So what you have to do is, sorry, you don't need to, in this case, you don't need to, yeah, give me a second. So in this case, so fourth question, first A part, let's say, derive the heat equation using the separation variable. They are fx equal to as it is, okay? After the B part, using fx equal to, let's say, x squared, derive the final answer. Bn is equal to what? This may be the second question. So you have to know how to do that, okay? But if you don't have this question, let's say only I have this, only this question, okay? In that case also, you have to derive full because it may be 50 marks no, or 100 marks no. So if you wanted to get full mark, you have to derive quickly. Derive it and at last you substitute it, okay? So even they may give you different boundary conditions, different, initial condition. So first of all, you derive with the fx, general equation. At last only, you have to substitute fx equal to x square. Okay. So even though they ask you the A part, you derive it and give the B part, rest of the B part. If they don't ask you to solve it, they are also, you have to derive it. Okay, derive and then only you have to give it. Okay. So if they don't ask you the A part, if it is a full question, may 400 marks or 50 marks. So you have to gain it by solving, deriving all. Okay. Okay, so I don't want to explain more, I guess. Okay, let me go back to the. Okay, hope you can incorporate all these, questions. I don't want to waste my time in fourth, third, second, everything. So if you, before examination, if you get all these answers, it will be good for you. Okay, so you don't need to wait. That's why I'm giving you my next week's time for you to prepare your exam. Okay. So even though like we have numerical analysis 2 exam, PD also I would like to have 2. Okay. I'm just making easy for you. But in this 2, I am having entire chapters. Entire course. Okay. So both are 2 credits. So I should have 4 exam. But because of the time limit, I'm taking 2. But I will cover full course. Maybe it may be the 1 day, it may be the 1 day. There's no time duration for us. So you have to prepare for the exam for this one, 18 to 21. Maybe 18 will be numerical analysis 1, 21 will be this one. Okay. Whatever the time we have, I will do the exam. Okay. So prepare yourself this week and next week. Okay. That's all you have to do. Prepare like a semester. We have finished everything now. I also giving you my recording, so it may help you more to prepare yourself, and I am expecting a good result from. Okay. Okay. So I would like to teach you the wave equation. Okay, and then we can finish up. Okay. So let's go for this one because I told you the heat equation. So I will go for this one. Okay. It has a little bit of, not the same thing, but a little bit of, because yeah, see here, what is the difference between the heat equation and the wave equation? Okay, so we have the heat equation has the form ut equal, let's say, alpha square uxx, one dimensional cases. Okay, for the wave dimension, wave equation, we have only thing is difference is here second order. This is the first order, this is second order. So there we need extra condition from heat equation. Okay. Heat equation, you can say, you can compare these two. Okay. See this one and this one. This is one dimensional case, same one dimensional case of homogeneous boundary condition. Okay, homogeneous boundary condition. So this kind of also available for the one dimensional. You can search as a reference. Okay, I didn't put. Here you can see boundary condition, same boundary condition. See here, same. The initial condition, okay, since it has only UT, one initial condition is enough. But in case of UTT, okay, we need another initial condition, which is a kind of this one, form of this. Okay, U of T. See, I hope you know the U to UT, then only know UTT. So to get the UT, we need only the U part. Okay, but to get the UTT, you also need this part also. The first derivative, initial condition. Okay, then only we can derive the final answer. Okay, these things also you should know, because in the boundary condition itself, we are only changing the space part, 0, L. Okay, T will be T now. So forever T will be any positive T. Maybe it goes up to infinity. Okay, maybe t is equal to 5, 1. Okay, tell me, is that possible to get a time in negative? Something less than 0. Is that possible? Do we find the time in the negative? No. Time is always a positive. Time is moving. We can't get the time. Likewise in our life also, okay? If you miss the today's time, it will be missed forever. You can't get it again, okay? Like that. Time is always a positive, okay? And in this initial condition, see here, the time they are taking as a 0. The time is equal to 0. What is the temperature? That's the idea, okay? So they are changing the x only. X will be there. What x equal to 0? What x equal to L by 2? What x equal to L? Okay. So I hope you please note down this also. Okay. When you are having one equation, not only in PDE, in any courses, if you have one equation, go through thoroughly and understand the concept. Okay. As a mathematical people, we don't have much, paragraph or those things. Only we have the notation. So if you understand the notation correctly only, we can understand the concept. Okay. All right. So, okay, let me use my time to do this one. Okay, I can do this in the whiteboard. Please write down with me also. Okay. Okay. So let me solve the second part of one-dimensional wave equation solving, okay, using the separation of variable method. Okay, since I have explained you the heat equation, I'm gonna go a little faster. I'm not gonna explain you each steps. Wherever the difference coming only, I will explain you. Other things I don't need to waste time, okay? So consider one-dimensional wave equation is what? Da bar squared u over da bar t squared. So this point of time, you have to know, okay? These stuffs. You better use the capital letter, okay? Okay. So let's go by step. So step 1, okay? So it's better you to go by step, okay? Then only you will remember, okay, how many steps I need to use, okay? So this is my wave equation, which has, So the boundary condition and initial condition, this is our step 1, okay? Boundary condition and initial condition, they were used like subject to, the boundary condition has been given as the Dirichlet, isn't it? Homogeneous. So 0, comma t, which is equal to 0. And also I have, let's say L, comma t, which is equal to 0. Maybe capital L or small L. That's not a problem. Okay. Initial condition. So if they give you small L in the examination, example, you have to use it. If they give only capital, you have to use as it is. Okay, don't change it. Okay. So if they give you in the in this question, what they have given? Capital. Yeah, capital. So you have to use the capital only. Don't use the simple, okay? Otherwise, it's a different one, no? So notation is a very carefully take it, okay? So let's say you initial condition x comma 0 is equal to 0, and one more initial condition you have ut of x comma 0 is also for the easiness. So this one is we have taken f of x. This has been taken as 0. Okay. So in the wave equation you should have 4. Okay. Okay. This is our step number 1. Okay. Okay, let's go for the step number 2. Step 2. There you're going to use the separation of variable method. Okay. Let u is equal to x of x, since in the wave equation also depend on x and t, isn't it? Okay. Xx and tt. Then, so see here what you'll get. You, for the easiness, I'm writing t square. I can write as u double dash, which is equal to, what do you think? This will be, if you take the derivative 2 times, the x will count as a, with respect to t, no. So x will count as a constant. Okay, it won't change anything. So this will only change. Okay, t double. Similarly, da bar square u over da bar x square, I can write as a, again I'm going to use as this one. Okay, prime only. I'm going to use the prime only. Okay, so better I don't use this. X double dash of x and t. Tt will be as a constant. Okay, so if I'm considering, PD is all about that one. No? If you consider one variable, other variable taken as a constant. Okay, so this will be only changing, otherwise not. Okay, before that, put this equation number 1. Okay, so shall I continue? Now, substituting these results in the equation number 1, you will get x t double dash, okay, t, it is equal to, for easiness, I'm writing, no need this t, okay, c square x double dash of t, okay, so I can separate x and t's in both sides, t double dash over t, for the, sorry, this is alpha square, sorry about that. So whatever the alpha square also you take with the t, okay, this one you can write x double dash over x. So if you have the separate one, if you want it to be equal, so this one I already told you, no, you have to have one of the constant, okay, where k is the common constant. So both are equal to the common constant, no? K is the common constant, okay. Okay, tell me what is our next step actually from our earlier lecture, heat equation, what we have done after this one. Can you elaborate the idea in the chat? What is our next step? Can you elaborate commonly? Go through the next step of heat equation and tell me what we have done after this. Same thing happening now. What we have done after this. Go through your notes and tell me what we have done after this. I'm waiting for you. Okay, good. Yes, others. Only I got the answer from 77, 94, and 03. Others are off or not in the lecture or what happened. There are 49 people here. I need enough responses, otherwise I won't continue. I can simply say you can refer it and then I will off the lectures. Okay. What will be the next step? Let me check the availability of others. 002. Can you answer me quickly? 020, 039, 095. Everyone, please quick answer for me. 130, 152. Otherwise, I will leave. Let you leave the course. Okay. I will not give you the attendance today. I need all the answers. So whoever I have asked only answering. Where's the others? So I'm marking your responses. Okay. So if you don't respond, I will somehow I'll put absent today. Okay. So this is a big question. It's about the cases of case. Can't you answer this one at least? We are analyzing the case of K. That is step number 3. Okay. So K may be, there are 3 K may be equal to 0 or less than 0, maybe greater than 0. Okay. So because you have made so many trouble here, I'm gonna have this there's no point to teach you everything. There's no use. All right, so case 1 and case 2 is yours. I can't teach you. Okay. So K is equal to 0, you can find out. Okay. K is equal to 2, maybe K less. See whether it is, trivial or not trivial. It's your reference. Okay. Whoever responses can contact me if you are troubling. Others, I won't give any answers. Okay, so let me go for the thing what we are up to. Okay, case 3, let me go for that one. So everything you have to put in the examination. Okay, so you have to, let's say K is equal to minus lambda square in equation number 1. Okay, I will have equation number 1. Yeah. So I may have two set of ordinary equation. Okay. So one is like a x. Yeah. So let me write this equation, not 1. This is okay. I'm gonna make 2, equation number 2. Okay. So you have to put this in the equation number 2 because K is coming here now. So in equation number 2, if you substitute this one, okay, you will have, let's say, t double dash over c square t, which is equal to x double dash of x, which is equal to k. Okay. So if you put minus lambda square, say minus lambda square, okay. So one of the, so actually the separation of variable is doing our PDE to 2 solvable ODEs. Okay. 2 ODE, ODE1, ODE2 in terms of x and in terms of t. As you know, ODE is about the one variable case. PDE has, let's say, x comma t. This has solved with 2 ODE cases. ODE is, simple, no? You already know, you are studying. So I'm not gonna waste time here. So you can, first of all, let's say x double dash. If I have minus lambda square, I can take this one plus, isn't it? So lambda square x equal to 0. So here, this is kind of a second order ODE solving. So there you can use d squared plus lambda squared of x. So this one is ODE. So I don't need to teach you, okay? So this is your part. Go through this and solve it and find, I think m squared plus lambda squared is equal to 0. Then m is equal to plus or minus I lambda, no? Similarly, this is also same, no? T double dash plus lambda squared. Sorry, I'm writing c square always. Alpha squared t, which is equal to 0. This is also like d squared, lambda squared alpha squared of t is equal to 0. And m squared plus lambda squared alpha squared 0. Then what is m? M is plus or minus I alpha lambda, isn't it? So you can put it in there. What is the final answer for this one? Can you answer me? Using the ODE, what will be the x? Can you answer me, anyone? T is equal to what? You may study it in the ODE, no? Did you study this in the ODE? Second order solving? You may, no? I think we also seen these things in the homogeneous case also. In our chapter 3 also we have seen this kind of solving techniques. So what will be the X and T? Please tell me using your ODE knowledge. Second order ODE. This is the section of so after this part we are in the second order ODE solution techniques. Solutions. So where's the answer? What is X? What is T? If you get imaginary answers, I lambda, or this is also something a constant, no? What will be this one? Go through your OD notes and tell me the answer. Okay. Okay, I got one answer. Do you need the exponential of 0? What is exponential 0? Already 1, no? Yes. Yeah, good. Okay, good. So what is this one? Okay, one of the student has answer. So you must be studied in your ODE. Okay. So this is not my part. So I'm gonna use your answers. Okay. Cos lambda x plus b cos cos. So cos. Check it. It should be sine, no? You have written the first one correct. Second one you have written wrong. Okay. This should be also sine. Okay. Lambda is. Check answer. Okay. Good. So if you take A, B, I can say C. This is also same, no? So cos alpha, same, no? Alpha lambda t, because this is with respect to t, no? T plus let's say d cos sine alpha lambda t will be the true answer. Let's say this is my 1, this is my 2. Okay. So correct. What about others? Go through the ODE notes also. Okay. That is also involving here. So write down these things. Okay, what is my next step? You already know all the steps I have told you in the heat equation. Just I'm showing what is the different case because it has 4 boundary condition. I mean, initial with the boundary condition. No, I wanted to show that step. That's my purpose here. I don't wanted to teach you this kind of. These are already I told you, and this actually from your ODE. Okay. All right. So I'm not gonna waste my time. Anyway, step number 4. No. Okay. Let's go for. So we have found our x and t. Hence, the solution of the PDE is, so actually using the separation we have found ODE, 2 ODEs. Okay, 1 ODE, 2 ODE. Then we have incorporate to our actual PDE. Okay, we are again gonna connect those two to our PDEs. That means u x comma t, which is actually we have taken as xx dt. No? So whatever you got the answer, you just put here. For example, sometimes they may also use like this for the, I mean, for here I have taken A, B, no? There they can use C1, C2, C3, C4 like that also, okay? So anyway, variable is not a problem for us. So let me use cos lambda x plus b sine lambda x times, okay, C cos alpha lambda t. Okay, so I can use here also this bracket plus d sine alpha lambda t. Okay. All right. So don't multiply this one, keep it as it is. Okay, let's say this is our equation number A, capital A. Okay. So after that, what do you have done? Go through the heat equation and tell me in a word. You can't type the, the variable, just tell me what we have to do. Okay. So what is the next step? We already found the answer now. This is actually, we have found the ux comma t. But the thing is, it is in cos lambda x, sin lambda x, alpha. Okay, that is also okay. The thing is, we don't know about the lambda. Lambda is what we have taken. We have to incorporate with some, but not only so far we have used our equation only now, but it is incorporated with subject to some boundary condition, initial condition. So we not yet used it. Okay, so that's what we're going to use now. Do you understand? Okay, now let's use the boundary conditions in our chapter. Sorry, step number. Maybe I don't want to put another step. Let's continue like that. Okay, so step now put the boundary conditions. We have two boundary condition now. So let's say u0 comma t is equal to 0. So in that case, a will be changed into, so what is happening here? So for the x, you have to put the 0. Okay. So x case, I mean in the a equation, the first one is the x case. Next one doesn't matter because it's depend on t. So this will be like c cos alpha lambda t plus d sine alpha lambda t. This doesn't change anything, but equal to 0. Okay. So what is happening here is a cos, whatever you multiply by 0, it will be 0 now, plus b sine 0. Okay. So what is the result? What is cos 0, sine 0? It's coming again to the trigonometry. Okay, what is sine 0? Can you answer me? What is sine 0? What is cos 0? These are very simple now. Tell me. If you are not sure, go to the Google and everything. Yes, good. So we have the answers. Sine 0 will be 0 as it is. Cos 0 will be 1, isn't it? So this term will be vanished. Okay. So this will be 1. A times, so the answer will be A times cos, whatever you have, this one, C the t plus d sine alpha lambda t. That's all. Okay. 0. So what do you think? This one. For example, let's say A and B are multiplied by 0. So what is our result in our school level? What are you taking? So how comes two variable multiplied will give you answer 0? Either maybe A is equal to 0 or B is equal to 0 or both are equal to 0, no? So what do you think? Is that possible to have A is equal to 0? Yes. So maybe this is equal to 0 or this is equal to 0. I'm going to take A is equal to 0. Okay. So this is my answer from this boundary condition. Okay. So from this, I can say okay, I'll continue in the next window. Please take down this. So since it is like so you have to understand, okay? So it says two variable. This is 1, this is 2. Either this is equal to 0 or this is equal to 0. Or you can write this is equal to 0. Okay. So it is commonly giving A is equal to 0. I'm going to take this answer. Okay. So what it leads to is, okay, in our next step, now in my equation number A, I'm going to substitute A is equal to 0. Substitute, just write down. Substitute the result A is equal to 0. Therefore, your equation will be reduced as to ux comma t. I will have only b sine lambda x times, okay, times c cos alpha lambda t plus d sine alpha lambda t. Okay. So what I am doing is I'm reducing my equation using the boundary condition 1 by 1. This equation will be reduced as to some nice form. Okay, let's say this is my equation number b. Okay, big B, or you can put small b or something. Okay. Okay. Now put again our next boundary condition. Now put the boundary condition of u l comma t is equal to 0. Okay, so already A is 0 now. So you don't need to consider A equation. Now it has been reduces to B. Now use this equation to put UL comma T. So what will happen? The equation will be reduces to L comma T. So wherever the X terms come, you put the L. Okay, so I can put sine P sine lambda L times whatever this one. C cos alpha lambda T plus d sine alpha lambda t. That's all. Okay. So now what do you think? Which is equal to 0 now? Since this is equal to 0. Okay. Now I have like this result. I have maybe, so like this. A, B, C all are 0 equal to 0 multiplying. So I can get either. Okay. I'll write nicely. Give me a second. Okay, maybe like A cross B cross C is 3 terms are equal to 0. Maybe A is equal to 0 or B is equal to 0 or C is equal to 0. No, that concept. This is one of the variable. This is one of the variable. This entirely I'm going to take one other variable. Okay, this is third one, second one, first one. So I may have the answer maybe B is equal to 0 or sine lambda L maybe 0 or this term. Maybe you write this one is equal to 0. Okay. So is that possible to have? Likewise, I took A is equal to 0. Is that possible to have the B is equal to 0? So think in a 1 second. So it is, we have taken already, okay? But I am telling, the thing is, if I take B is also 0, okay, let's say, let me take another color. If I take B is equal to 0, so this full term will be 0 now. If I take B is equal to 0, okay, see here, my, this one. This is my final answer I got. If I say A is also already I have found 0. So if I wanted to get the trivial solution, I mean, non-trivial solution, I should keep the B. I should safeguard the B. So I need to have B not equal to 0 in any case. Even though A is equal to 0, I should have B not equal to 0. So if B is equal to 0, I should have A not equal to 0. Okay, this is our choice. Did you get that? So in that reason, what I'm saying is not equal to 0. This is not equal to 0. So I'm safeguarding this because since for non-trivial solution. Non-trivial solution. You should know, no? u are not equal to 0, non-trivial solution case. Okay. So maybe, so I have left out this one. Okay. I have left this one. Sorry, I can take. So I have left this one. Okay, this is not our problem. Okay. So either I can take this one or this one. So I need to safeguard the time variable. If I say full time variable will be 0, so that is also non-trivial, trivial case. So this is also I'm not taking. I'm gonna take this one only. Okay. So since two, I'm gonna take this. This one is the correct form of this choice. Did you get that? So whatever I'm telling as the extra things, please note it down with a pencil or anything. Okay. So when you are studying also, you can use it. It seems a big process, okay, but very simple. If you do this again 1 or 2 times, it will be very handy. You can do it quickly. Okay, when I explain only, it will take times. Okay, okay. Let me go for the next steps. Please take this screenshot or this write down quickly. Okay, let me go back. Okay, there I have found sine pi L is equal to 0. Okay. In what situation, I have explained you this one in the heat also, no? In what situation you will get a sine, any function will be 0 in case of sine, let's say m pi or n pi, okay? Sorry, n pi, where n is any integer, for example, sine integer in the case 1, 2, 3, no, 0, 0, 1, 2, 3. So sine 0 also 0, sine pi also 0. Sine 2 pi also 0. Whatever the multiplication of pi will be 0. So therefore, we are putting and as a general case, sine n pi will be 0, where n belongs to integers. Okay. Therefore, I can equate the sine, if I take inverses, I can take lambda L is equal to n pi. Okay, where n is an integer. So I can say, right, nicely. Okay, therefore, the purpose is to find the lambda, not lambda actually we have take. So we need to find something related to it. So wherever n is equal to integer. Okay. So I have found a way to take down the lambda. Okay. Now, therefore, so I don't need to go back to the equation number A. B is enough. Therefore, our equation B comes as wherever the lambda, you put the n, okay, n pi over l. So ux comma t will be turned into b sine n pi lx times, so write down this one, c cos n pi over l alpha t plus d of sine n pi over l alpha t. So take down this is as a equation number C, or small c or capital C. That's your choice. Yes, still we have a big equation, okay, solution. So to get rid of any of the t terms, okay, we are going to use our one of the initial condition. That means ut initial condition. Okay. Okay, let me continue. Now again put the initial condition. So we are keeping our one of the functional initial condition for to find the constant bn, but another ut what is that, 0 comma, sorry, x comma 0 ut x comma 0 is equal to 0, initial condition to take off one of the time derivative. Okay. Now differentiate. So to get that, see here, we have to put this equation where. So actually, our C is what, ux comma t something, no, b sine. So you write down this one, whatever, c plus d. Okay, but actually we have u. So if you wanted to put this one, you have to differentiate this entire equation with respect to t. Okay, so now write down differentiate equation number c with respect to time t. Time t. Okay, can you do that? Da bar u over da bar t of x comma t, which is equal to this one, sine pi x over L, n pi x over L. So we are differentiate with respect to t, partially. So partially, you can write partially. So no need to consider this one. This one will become as it is, okay? It's like a constant. So only thing will be then here. This is like cos, no? Here cos n pi over L alpha t plus d of sine n pi L of alpha t. Okay. So here only gonna change. So if I partially differentiate this one, what you'll get? You will get c times. What is the differential of cos? Will be minus sine, no? Sorry. Sine n pi over L. This is just a differentiation, partial, okay? T times. So I need to, so it's like this one. Sine 2x is what? So 2x with respect to x will be da bar sine 2x over da bar x will be, sorry, cos will be minus sine 2x times 2, no? So you have to differentiate inside function also. So like that, if you inside function, if you take off, you will get n pi over L alpha. Am I right? Yes. Next one, d times, sorry. Sine differentiation will be cos, sorry, cos n pi over L alpha t times same way, n pi over L alpha. Okay. Is that correct? So we have only 5 to 10 minutes. Please make up quickly. Okay, so this is the differentiation of this one. Okay, so here only I am gonna put my let's say this is my equation number D. So this D and D, if you can't find the difference, just put the small d. Okay, A B C D like that. Okay, it's not a problem. Okay, let me go quickly. So if I put my x comma 0 t is equal to 0 for this one, I will have the equation number D will be changed into D of sine n pi x over L times minus C sine n pi, what happened? N pi L. For the T, I need to put 0, no, times 0 plus D times cos n pi L of alpha 0, which is equal to 0. So I know you already have saying sine will be 0. Sine 0, this will be sine 0, no? So you can write the next line. Sorry. Sine n pi over Lx, which is equal to minus C sine 0 plus d cos 0 is equal to 0. Okay, so this will be 0. I already know. So sorry, this will be b. No? So altogether I have b d. Okay, sine. This will be 1. So b d sine n pi over l x, which is equal to 0. Okay. So yeah. So okay. So I need to get rid of any of these variables, C or D. Okay, so I found BD sine pi x over L is equal to 0 now. So what I can take? D I already taken, not equal to 0. Sine pi x over L also I don't wanted to get rid of. So I can only take this one as where D is equal to 0. Either any of this may be 0. So I would like to have this D is equal to 0 for the non-trivial equation. Okay, non-trivial case. Non-trivial solution. So we have come to the last point. Okay, so my final, what is actually, oh yeah, here, no? So B, this is our final equation. No? We have reduced A is equal to 0. This is my final equation. I have taken this one also 0. So this is my final answer. Okay, that's what I'm going to write. Therefore, from equation number B, I can say my u x comma t can be written as b c okay, sine n pi lx time cos n pi over L alpha t. See, I have reduced this to very simple form. So for this, I can write, let's say, Pn or Cn. Okay. So after that, if you have n is the integer, no? So for the 0, 1, 2, 3, it's like that. Okay. I'm going to incorporate this under the summation. Okay. Summation where n is equal to 1 to infinity Cn of. So I'm going to take these two as a Cn. Okay. Since n is also depend on the constant. Okay. I'm putting Cn. That's all. N pi L over x cos n pi over L alpha t. That's all my final answer. Yeah, so I will give the Fourier series for this. Second. So yeah, no need this. So it will be so to get the Cn, you have to use the Fourier series. Okay. So I don't have that much. Okay. So you can refer this one. I don't think so. Cn is equal to, so likewise in our heat equation, Bn is equal to 2 over L, 0 to L, fx sine pi x over L, ex, no? M something. So here also you will have something like that, okay? So I will find it now, okay? If I find it, I will send a picture for this. Okay, anyway, so that is that. So this is what we need, okay? So on that question, okay, give me a second. So in this question, I have solved it, okay, for the fx case. Yeah. So this will be the final answer. So they ask you to one-dimensional wave equation solving using the separation variable of Dirichlet boundary condition of. So I just wanted to show you how to use this one. So there you have to take the partial derivative with respect to t and then use it. Okay. So I hope you know this construct. Okay. So if you wanted to use this one, you have to take whatever ux comma t, you can take the partial differentiation with respect to x. Okay. So anyway, this is how the questions come. Nothing a big deal. Okay. So yeah, that's all. So I would like 42. So I would like to yeah, that's all about our chapter 4. Okay, I will go through a summarization and then I will finish. Okay. Okay, this is all about our course partial differential equation. So we have the aim to provide. Yes, okay. Okay, our aim to provide a basic knowledge in the theory of partial differential equation, as well as to use it to solve boundary value problems that we have studied now. Those arises in the field of mathematical physics. Okay, so mathematical physics in the sense physics is incorporated with the mathematical solving processes. Okay. Also, let's see the learning outcome. See whether we have reached all these outcomes. Okay. First of all, you have to define the basic terms related to partial differential equation, as well as classify according to linear, semi-linear, quasi-linear, as well as non-linear. So hope you know these things. Okay. Then also we have used some elementary arbitrary constant and arbitrary functions to eliminate to get the PDE. Okay. Okay. Next one, we have solved our first order linear PDE using the Lagrangian method. Okay. There we have used a quasi-linear case. Also, we found some nonlinear solving using the Chapitz method. We have solved the nonlinear cases. Okay. Also, we use second order PDE with constant coefficient. Also, we use the homogeneous case, isn't it? So next one, let me go back to the course content where I have divided into 4 chapters according to the question I am going to take you in the semester. So first one is about the interaction, basic definition, classification, and solution formation. Okay, this kind of will come under chapter number 1. And then chapter 2 is first order differential equation of linear and Lagrangian equation. Non-linear case, we use the Chapitz method. Okay, also characterization and all. Third one, second order, where we have learned how to solve the homogeneous with constant coefficient. Okay, that's one. There we have used our canonical form as well as what is a CF particular solution and all. Okay. Next one, in the chapter 4, we have used a separation of variable method to use our famous application of the equation of heat as well as wave. Okay, I'm just give you this as a reference. Okay, it's a boundary value problem, how to use the Fourier series and all. Okay, so that's all about our course content. You can also use these reference to get some extra references. Also, as I said to you, I'm going to take two main continuous assessments which related to chapter 1 and 2 for one exam, 3 and 4 in one exam. But semester, you will have all these as a 4 questions. Okay. Semester, you'll have a 4 question. Here also, I don't know whether maybe 2 question or one exam, or maybe it's depend. Okay. According to your time limits, we can have it. Also, we have 18 to 21, 1 day for the numerical analysis, 1 day for the PDE. Okay, so please inform me early as possible your arrival, and if they announce you the time for your practical, please give me 1 hour, or half an hour for the examination. Okay, so if it is half an hour, 1 day for the numerical analysis, and 1 hour for the PDE for the 2 exams for the PD. Okay. Please let me know earlier. And I'm going to finish today itself. I'm not going to take next week. So you can use the next week as your study week for the continuous assessment as well as semester. Okay. So that's all about our course. I hope you have gained all the knowledge about this course. And I'm expecting good results from you. Okay. Please study well, and I will also upload your videos soon. And the next one is, the evaluation form. I only got like 38, 39 responses so far. So I want you all to, there are 55 students now. So I wanted you, I don't get time now. Others, whoever the people who wanted to go, the mosque, you can leave. But the others, please respond me quickly. All other, there are some 20 people. Less than 20 people are not fill the form. Please fill it and answer me quickly in the group. Please put the done after you finish. Take this moment to fill out the evaluation form. I will wait for you around 10 minutes for your responses. So I'm taking down whoever put the messages. Okay, there are 38 students only responded. Can you take your time to fill now? It only take 5 minutes now. Can you finish? So the examination purpose, you can, prepare yourself how you can answer the homework quizzes, okay? As well as some definition in your notes, okay? That's how I would like to take some question. Also, you can refer your past papers to see whether you can answer all the questions. Okay, please respond me who will not fill the form. Do it now and respond me. I can wait until 12 o'clock. Whoever want to go to the mosque, if you finish filling, you can leave the session. Okay, I got only 5 responses so far. Others, are you filling? Okay, so I'm leaving here from the Zoom, and I will upload the video soon. Okay. Okay. Take care, everyone, and best of luck for your preparation for the examination. And okay, thank you.